Welcome to Energy Talks, a regular podcast series with expert discussions related to power system testing. My name is Scott Williams from the podcast team at Omicron Energy Solutions, and I will be your host. In this first episode, we will be talking about a topic that is becoming increasingly important to both manufacturers and operators of electrical equipment. I am referring to the testing and monitoring of partial discharge, also known as PD. PD testing and monitoring play a critical role in assessing installation condition, focusing maintenance efforts, and preventing premature equipment failure. There are various methods of PD testing and monitoring, but when is each method ideally used to detect potential failure causing installation defects? What are their differences and how do they complement each other? With me to answer these questions and to offer some insight is Patrick Sander. Patrick is a specialist in PD testing and monitoring at Omicron. Hello, Patrick.
Hi, Scott. Thank you for having me today.
Great to have you. Also with me is Samuel Scheller. Samuel is the Omicron product manager for PD monitoring solutions. Hello, Samuel.
Hi, Scott. Thanks for having me today.
Thank you both very much for being here for this discussion. First of all, Patrick, I would like to start with you. Could you explain the importance of partial discharge detection in electrical equipment?
Yes. So the installation, or rather the condition, is a major reason why assets do fail, right? So of course, this is not the only reason why they are failing, but as a consequence of that reason to assets that they are failing, we need to assess that condition or the quote health unquote of the installation system. So PD testing can be used to perform such assessments, right? There are many other tests as well, but PD can pinpoint even the smallest problems that may occur, right? It's not just a relative measurement, but when you do have a problem, PD testing can really show you that problem. Also, most of the international standards like IC or IEEE recommend or even require PD testing to be done in your asset.
What types of electrical equipment are we actually talking about?
So typically, if we speak about assets, right, we instantly thinking of rotating machines, transformers, switchgear, or power cables, for example. But of course, this is only a limited overview of the electrical apparatus that we have in the field. So PD tests are also performed to assess material or parts of electrical assets. So it's not just only limited to already manufactured and assembled assets.
Okay. When is PD testing typically performed? And what in particular are we looking for?
So in general, PD tests are done when people want to verify the product against certain limits. Like normally this is done during the factory or site acceptance test of these assets. So I'm talking about an after installation test, that is the site acceptance test, or after finishing the product as an end-of-line testing, the so-called factory acceptance testing. So this is not only limited to these things, right? Also during the pre-qualification stages, type test, or the pure development phase of different parts of the assets, PD tests are used to assess these parts, these material, these assets during the manufacturing process, during the development process, and all these things. And it's not just limited to these type of mandatory tests, right? PD tests are also done during outages, turnovers of plants or factories, and also done during scheduled service windows of all kinds of assets. To make it short, basically in general, whenever one wants to assess the condition or the quality of the installation system or part of the installation systems, PD tests are done and can be used to verify that.
Okay. Now, so Patrick, at what point does regular PD testing become beneficial?
Well, sorry to say this, but it depends. But in general, when the asset is aging, you should intensify the testing. Whatever method you might consider is good, but obviously PD testing, as it's very specific to the defects which can happening over time, PD testing is a valid way of doing that. So we're talking about assets which are already installed. We're talking about assets which are in the field, right? So for these types and for these ones which are on site, online, and so on, it's not just that one test would do the job. It's not like you go there and you have an absolute assessment of your asset today. So you want to correlate different measurements. So that could be different methods, but also different measurements which have been done in the past to get a better overview and to assess these values, these tests that you have been doing in the past, and with your current measurement to have a valid status of condition. And this also leads to the increasing demand and the trend for going into PD monitoring. So it's not just about testing, but there's also a slight change to doing regular testing every now and then, can be scheduled or can be based on certain criteria into permanent PD monitoring.
Okay. So speaking of which, PD testing is typically performed offline, but it can also be performed online. When is one method used over the other, and what are the key advantages of each?
So as mentioned before, offline tests are usually done in the lab, for example, or factory acceptance testing. Mm-hmm. So these ones are the considered tests when you want to achieve a certain value. For example, if you look into the international standard, one might say for power cables, there's 5 picocoulomb as an absolute limit, defining whether the cable has PD or the cable doesn't have PD. So in this test, because it's very sensitive, this cannot be done online, because the noise influence is simply too high to allow that, right? So you have to go in a shielded environment of the lab in order to facilitate that test. But it's not limited to that. Offline tests are also done at certain scheduled maintenance assessment. Like said before, during the outage of the plant or the factory, for example, if you look into a power plant, into a power generation plant, for example, every 4 years or every 8 years, you have the major, every 4 years, you have the minor overhaul. And PD tests are done on the motors or the generator, just as a fixed scheduled test. And this is very good because you're very sensitive. You don't have that noise influence. But of course, this is only part of the overview, part of the status of the condition that you can assess like this. In comparison to that, online assessments have the benefit that are representing the real scenario with all the online conditions, not just the cold machine, for example, that you're seeing right now, but your real deal. So everything what is happening online during the normal operation, you might see as well. But of course, that is the limitation that comes with being online. You have a lot of system noise, a lot of ambient noise influencing a measurement. And having said that, only a combination of both methods at the right time, so during scheduled measurements, during factory tests, and so on, can solve the problem. So it's not just you do offline tests, you either do offline tests or you only do online tests. It's always a combination of both methods that solve the issue of the customers, right?
Okay. Super. Well, thanks, first of all, Patrick. Samuel, I'd like to ask you a few questions. At what point should continuous online PD monitoring be used, and why?
So it's a point that really varies according to the asset type, as well as how critical the asset may be in the actual network. If you have a critical asset, it's generally advantageous to start monitoring immediately because you want to make sure that this asset is always online. If it's not a critical asset, you may consider never to do any monitoring because you'll just run into destruction because it's not critical. However, there is certain aspects even under which you would consider doing monitoring because maybe lead times are too long for you to accept an outage or a downtime if an asset does fail. And also, if you have something that is a critical asset, you may decide not to do it straight away because you know that it will have numerous years before actually ever presenting any issues. So you could say, okay, once the transformer, for example, starts getting a bit older, or the rotating machine, that it starts making sense, you would maybe start, if you see it during some scheduled maintenance and, let's say, testing with offline or online PD testing or diagnosis, you see, oh, there's a problem here. You could decide then to start monitoring and track this development. On the other hand, it's also useful to do it in the beginning because then you get a fingerprint or a, let's say, healthy state of what the PD looks like in operation. And because we can't really calibrate like you can with offline in online, you can only see it in relative terms. So you can only see that a relative increase over time with all of the other effects that are in the network. And it's more useful to have over a longer period of time. So you can see, okay, this is in a healthy condition, and over time, there is a developing fault. To just do it later in the asset's life, you may not be able to understand how high is my PD level really in comparison to a healthy asset.
Okay, good. So comparison is very beneficial there.
Yes.
I understand from you there are two types of PD monitoring. We've been discussing this before. One is short term, and the other one is permanent. When is one used over the other?
So, as I kind of mentioned already, if you have a developing fault or something that you've discovered during a offline test or an online test with your diagnosis or your maintenance, it could be sensible to do temporary monitoring just to see if that problem develops or not.
Mm-hmm.
If you have a large number of assets that you want to check, maybe just once a year for a month or a few weeks, just to see how they're doing, to get a bit of a trend, because you have a very large number, and you want to limit the number of euros or your budget to what you spend on, let's say, doing monitoring, because you don't see it as absolutely critical. Temporary monitoring is a good solution because it gives you, let's say, longer trending information than just doing a measurement. You can leave it on longer or shorter, even for up to a year if you'd like, to see how something develops. And if it stabilizes, you can take it off again. Permanent monitoring, on the other hand, is completely fixed. It's installed and you can't really change much. So if you see nothing developing, well, that's just data that you'll be collecting. But on the other hand, if there's something that only happens at a certain time of the year or only happens sporadically, and you can't always predict that, even temporary monitoring may not pick that up. So if you do have situations, for example, big switching or transients or some form of effect that takes place on the grid, you may not be able to synchronize that with your measurement of your asset if you do temporary. So monitoring permanently has a number of benefits, particularly for such, let's say, short-term event or things that happen over a few hours or days.
Okay. So I think you've answered this already, but just to reiterate, what is the key information that PD monitoring can really deliver?
Well, this is something that comes back also to PD in general. PD is an extremely effective indicator of insulation health. As Patrick mentioned earlier, that's why we test it. Now, monitoring is not governed by any stipulation of law or rules. It doesn't even have a standard. It only has a tech spec for rotating machines that stipulates that you should use or recommends you to use. However, of course, there are many associations, including SIGRATE, that recommend certain measurements and also monitoring. Now, what monitoring does of PD, it tells you if an asset has a healthy, or let's say, a non-changing electrical insulation system, which means you have nothing to worry about. If it's changing slowly, well, the asset is aging, so it doesn't mean much at that point in time, but you should maybe keep an eye on if it increases. Or if it increases rapidly, or it takes big steps, or increases at a very steep angle, you could say, that's when the operator should be alarmed, or at least be warned that there is a big change happening in his insulation system, so that he can maybe start looking into it, perhaps even do some planning to do additional maintenance or even a replacement of an asset before time. So it's really an indicator, like a traffic light, but that's a little bit oversimplifying it, on how good is his insulation system.
Once you start PD monitoring, should you also continue with diagnostic PD testing? If so, how do they complement each other?
Well, they're very complementary. As I kind of mentioned already, is if you're doing regular testing as part of your times-based maintenance schedule, you may discover that there is some PD at some point when you're doing a test. So that's when monitoring potentially, or at least temporary monitoring, could come into it, or even permanent monitoring. And it could be the trigger for monitoring to take place. And then you could actually adapt your time-based scheduling onto a condition-based scheduling. So if you see that something is deteriorating, that you start scheduling your maintenance intervals sooner. Or if it's not changing, you could even defer it, which could save you also a significant amount of money. On the other hand, or inversely, you could say, if you have a monitoring system installed, particularly on some assets that are very low maintenance or have no maintenance, you wouldn't necessarily have to do testing until you start seeing maybe something develop. So then you would maybe take an asset offline, do an offline test, or even do an online test to get a more detailed analysis, because monitoring essentially is looking at a far less information in terms of detail and criticality and reporting than, let's say, a diagnostic measurement will. A diagnostic measurement will be far more higher resolution. It will have far more tools to be able to analyze the data than the monitoring system will have. So they definitely complement each other, because the resolution and depth of the information you get from a monitoring system will always be inferior to that of a diagnostic system.
Okay. Thank you, Samuel. I have a few questions for both of you now. Here's the first one. Do you think that PD testing and monitoring will grow in importance in the future? If so, why? Patrick, let's start with you.
Sure. So there's a short answer to this. Yes, definitely. So this trend has been in the industry for years. People want to achieve certain concepts like the big data, Internet of Things, or something similar to this. Mm-hmm. So this is going into the direction of both monitoring and testing. No matter where you get data, so no matter from where you generate the data, it is okay to go into these concepts, like I just mentioned, like Internet of Things, big data. Mm-hmm. It's because the asset owners want to have more information about their assets. So these owned assets should become more digital in order to correlate more and more data points with each other to really get a kind of absolute assessment. This is not only limited to PD, but people want to generate as much data as possible to correlate every data point with each other and have a proper assessment. So yes, this industry, this trend in the industry has been going on for years.
Okay, good. And Samuel, what do you think?
Well, as Patrick mentioned, digitization is something that we can't avoid anymore these days, and it's happening everywhere, including in our industry here. But the other aspect is that not just because of the digitization, but our, let's say, hunger for electrical energy has been growing exponentially over the last decades. And more people have access to electricity, more and more people use it. And we can't even imagine our lives anymore, our day-to-day lives, work or private, without electricity. So the demand and the pressure on the providers of energy, so the asset owners or operators, is increasing with it exponentially. They have less, due to price pressures in the market, they have less money to do this maintenance. So they have very high asset reliability requirements and very little money to do so. So for them, it's very important to be able to optimize their maintenance and really make sure they can have some form of assessment or indicator how healthy their asset is. And this is what PD can provide or be part of the picture for.
Okay, thank you. Lastly, if there is one thing that you would like to emphasize to our listeners about PD testing and monitoring, what would it be? Patrick, what would you say?
So one thing, definitely do it. Because this will help you reducing the risk of unplanned catastrophic failures. Definitely do it. This would be my suggestion to every customer out there.
Okay. And Samuel?
Yes. Well, I would put it as PD monitoring is like having a smoke detector in your home or multiple smoke detectors. It can't necessarily save your life by carrying you out of the house if there is a fire, but it can alert you of a problem. And through your own, let's say, understanding of your house, in this case, your assets or your fleet, can you combine this information to make sure, is it a problem or not? For example, if it's lunchtime and the smoke detector in the kitchen goes off, you're not going to be jumping up much. But at 3:00 in the morning, you'll be grabbing your children and your car keys, perhaps, and your wallet to run outside and then check afterwards where the smoke is coming from. So PD monitoring is the smoke detector for electrical assets, you can say.
Okay, interesting. Well, I'd like to thank you both very much for highlighting the differences between PD testing and monitoring, and also explaining when they can be used to assess installation condition and electrical equipment. Thank you very much for being a part of this discussion.
Thank you, Scott, for having us today. It was fun being here, and I think at these times we really have to say take care and stay safe.
Definitely.
So thank you from my part. I'm also very happy to be able to take part in this. And I also agree with Patrick, stay safe, stay healthy.
Definitely. Thank you very much again. And a big thank you to our audience for listening to this episode of Energy Talks. We welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in PD testing and monitoring and offers you the matching solution for your application. Be sure to visit our website for more information at omicronenergy.com. Please join us to listen to another power system testing topic in the next episode of Energy Talks. Goodbye for now, everyone.